Hey guys, Kodo Canis here. Welcome back to the bench. So, if you watched my last episode, you'll remember this diagram: laser controller board, three relays, and a temperature humidity sensor. So, without further ado, here is the actual wired up stuff which we finished last episode: three relays and a temperature control sensor, nano connected to the PC over here. So, and keyboard, of course. So, let's get started and get some code in. So, first off, let's begin the standard. Let's set up the serial. So serial.begin 115200. Maximum speed we can go. Uh, just a second. Uh, still have my magnifying glass on, which is uncomfortable. Right, so let's begin the serial. We can now see what's happening. And let's just start off with by going pin mode. Now, pin 2. What did we say? It ended up being 258. 258 output, because those are the pins connected to the relays. So those are relays, and then the pin to the temperature humidity sensor will be controlled by that library, which we'll sort out in a minute. But let's start off with just simply going delay 1000 pin was it digital right. Let's actually give them some names for these. So hash define pin 4 laser enable is 2. Hash define pin pin 4 the lights is 5, and define the pin for the fans 8, and then we'll also define the pin for the temp humidity sensor being 11. We're not using the first one, the last one yet, so go 2, 5, 8. Let's turn the laser on. Let's make that high. And then what we'll do is we'll just turn them all on in sequence 1, 2, 3, and then 1, 2, 3. Turn them all off again. So low, low, low. Then we do lights, lights, and then fans, fans. So they should all come up, then turn off. Let's upload that and see what happens. And then I'll show them in. Is it actually visible? I shield them there, you can see lights coming on. Off, on, 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 off, off, off. Yeah, my studio light's a bit bright, but there you go. You get the gist. So they're ticking away quite happily, so we know that works. So let's just make this a bit bigger on my screen so I can see what I'm doing. So we've got those working. Let's just create ourselves a few functions which we'll need later on called void turn laser on, which is that one. Funny enough, turn laser off is low. And then we'll just copy and paste those 3 times. 1, 2, 3. And this one becomes lights, lights, fans, fans. And then we just lights, lights, fans, fans, and then we just delete all that and upload that to stop everything clicking because it gets annoying fairly quickly. There we go, clicking has stopped. So we know that that's how you can turn laser, well, enable the laser. It doesn't turn the laser on, it just means that the control board can then enable the laser. Lights on, which is just inside the main laser burning cavity so I can see what I'm doing easier, and fans to extract the smoke because I want to be able to control them remotely. Now, we have this DHT11 sensor, so let's install the library. So manage libraries, DHT11. DHT11. That sounds pretty good to me. Oh, there's quite a few. DF Robot. Oh, DF Robot's pretty good. Adafruit. Adafruit are pretty good as well. Not that I'm dissing any of these other people's, but I'm going to go for the one from Adafruit just because I like their stuff. Install. Unified sensor. No, I don't. Let's not worry about that one. And what's the first one? Library use super fast. Choose with Nano. Oh, okay, that one's an interesting one. Adafruit. I don't want to do the unified. Don't know AMD 16. I don't know any others. Grove. Okay, interesting. Don't have a Grove sensor on mine. Minimal. Is it, oh, it's so tiny. The one we were just looking at wasn't it? Or was there an Adafruit up here as well? Oh, so what's this one down here? Tiny. Install. Tiny liquid crystal and tiny wire. Nah, too complicated. Simple DHT. Oh, there you go. Oh, okay. You've only got a 1 hertz rate of sampling for a DH11T. Let's install this one. What the heck? Simple DHT. So, just excuse me for a second. I might just do a quick search for the library. It's on GitHub. And there should be an example. That looks really easy to use. So, standard thing to use. Go to GitHub, find the example. So, simple DHT. We first off say we want to use the library. Then we say simple DHT11 because that's what we've got. 11. And we'll call this one DHT. And then you pass in the pin. Pin, temp, humidity. So that's up and running. And come down here, loop. Now, on the comments for this, we can only do this once a second. So let's wait every 2 seconds. We'll do DHT dot. What do we do? We do a DHT dot read, passing in a variable which we need to dereference for the temperature, humidity. No. Have a look at this. So we have a byte. Interesting. Does it just read C directly? Interesting. Oh, might switch another one for a slightly higher resolution, but we shall see. So temperature, humidity, and then we do 0.print print line temp. Never used this library before. This is half the fun. 0.print Let's verify that to make sure it looks reasonable. Compilation. What do you mean? No signal. Sketchbook, verify. Ooh. Upload. Never had this before. Cool. That's correct. No. That's correct. I'm using the old programmer. Here we go. That's interesting. Right, standard approach. That doesn't work. I'll switch it back to the workbench while I shut down and restart the IDE. So, never had that before. Come on. Right, that's back up. Verify. It's working now. Okay, so switch back to that. Yeah, it's working now. I don't know what was up. So I don't know what this. Oh, there we go. Right. Let's upload that. Weird. And let's get the serial monitor going. To 28 degrees C, 39% humidity. Yeah, that feels about right. It's relatively hot here today. 37% humidity, probably about right. Actually, let's just see what the weather currently says we are. Weather system says so currently we are feeling like 24, 25. We're inside a shed, so yeah, that's probably not far off. But I'm a bit worried about this lack of precision. I would like to do a bit higher. Is that as good as it gets? To get more available information, if it's available for DH22 for DH. Interesting. I'm just sorry, I'm just checking the resolution. So DHT11 sensor resolution. No, it's going to me. It should give me point. Wow. It's at 25C. It's plus or minus 2 degrees. This resolution is terrible. But hey ho, it is what it is. Yeah, resolution. Oh no, it is 1 degree. I need to get myself a DH22, which is 0.1. But it's almost 4 times the price. So. Hey ho, that's what it is. So that's what we get. That's our resolution. So that and that. So it is what it is. So first off here we do void obtain temp humidity, and then we'll do the same thing. Byte temp, byte humidity, and then what we can do is move that up to here, and just rather than passing that, we do that and that. So that will pull in, excuse me, those two. Right, so we now have the ability to turn off and on various stuff and obtain the temperature. So now we do what we did last time. If you remember, is start copying and pasting from other code bases. If you're a software engineer, you understand that's the best way to get stuff done at times. So first off, how big of a buffer we want. So basically how much data we're going to store at most, what index we currently are, and these are a couple of flags. Go and see my tutorial on how all this stuff works because it's not complicated. I've got a whole tutorial on how this stuff all works and writing it. So then we come in here, scroll down on this one, above the loop, go paste that, and then we just want the loop, which is that. So what do we got? Every time around the loop, we update the serial buffer to see if we've received a command. If we've got a full command, process it, then start looking for the next command. So if we have command, we shall call this one. What have I called it? Laser. Just looking at the actual controller software I've written. There is another, what's the name? Module video that I'm going to have to make on how I actually write the controller software. So if we send an ID, we want laser. Then if we have a command reading, we want to return. Oh, that one to start the command. That to finish the command. And then this one is obtain temperature, humidity. What have I done? I've deleted those, haven't I? Yes, I have. So byte temp, byte humidity, pass them into there, temp humidity. So let's output those first. So obtain them first and then do serial.print temp, temperature, serial.print a comma, because that's how I'm separating stuff, and serial.print humidity. So that looks reasonable. And then the other commands you'll get will be laser enable. I've already got these coded, so laser enable disable, fan lights, disable, disable, disable. This will be fan, fan, lights, and lights. And funny enough, turn laser on, turn laser off, turn lights on. As you can see, that's not exactly complicated. I could start storing flags and doing a whole bunch of clever stuff, but nah, it's just, I like the code in such a way that I can easily understand it. If in a couple of years I come back, look at this code and go, what was I thinking? And that, I think, is probably about it. So the joys of cut and paste, once you've done it a few times, I really need to extract this into a library and then pull it into all my other code. Let's see what happens. Let's verify that to make sure it looks good. That's good. Let's push it up. Get the serial monitor running. So the serial monitor should now be blank. Who are you, please? You're the laser. Can I have a reading, please? It's 29 degrees, 36% humidity. Sweet. Can I... There you go. And if we flip back to the actual workbench, you can see that this one here has got a light on. It's a bit hard to see, but there you go. It's got light on. And then if I send fan disable. There you go. Nope. There you go. It turns off. That's working. Sweet. So there we go. The software for that controller board, which is going to go into the laser cutter over there in the next few days. Wire that all up, and then I will then get back to showing you the controller software, which is somewhere around here, connected into these things. Now we can get the whole lot working together, wiring, turning stuff on and off, and all that goodness. So hopefully you've enjoyed that. Like and subscribe. Press the button which is down here somewhere, I think. Leave any comments below, and hopefully you found that enjoyable. And I'll catch you next time. Bye.